Current aquaculture practices have a significant environmental impact due to their reliance on unsustainable production methods. Furthermore, Europe is not producing enough seafood to meet demand and is thereby having to rely on global imports, which causes a further environmental cost. As aquaculture presents a variety of challenges, innovation is vital. EIT Food has identified the following challenges that we feel are the highest priority. The first is implementing technology to optimize farm management, to minimize any losses while keeping food safe and reducing the environmental impact. The second is that we must start fostering emerging sustainable production, processing and transportation systems, including protection of animal health and welfare. The third encompasses extending the use of a digital marketplace, supply chain solutions, and collaborative platforms to democratize access to fresh seafood, improving sustainability and thereby increasing market confidence and consumer trust. The fourth challenge is developing sustainable alternatives for fish feed. For example, by obtaining alternative protein sources that could lower the environmental impact of aquaculture, providing a cost-effective source of feed, thereby increasing competitiveness and promoting the growth of new supply chains. By 2030, aquaculture could provide up to 2/3 of global seafood consumption. Therefore, it is paramount that as Europe scales up its production, sustainable practices are implemented at every step in the food chain. Moreover, significantly less GHG emissions are produced by seafood than that of livestock. Therefore, favouring aquaculture production would have a direct and positive impact on sustainability. In addition, given the clear health benefits of a fish diet and increased consumer awareness of this, increasing access to seafood will lead to healthier food choices, and the diversification of protein sources will potentially reduce the spread of non-communicable diseases. In summary, the growth of sustainable aquaculture is imperative. We must transform, grow, and maximize our aquacultural practices into smarter and more sustainable circular systems along the entire supply chain that support our quest to find healthy and sustainable solutions for our society, while ensuring food security and supporting the European economy. EIT is aiming to develop an inclusive strategy for sustainable aquaculture, and has therefore asked a variety of European internal and external experts to provide their contributions.
Innovation is in the DNA of European aquaculture, both in the traditional methods of fish farming and in the most technological systems, and also in all the intersections between them. But aquaculture in the European Union is not developing as successfully as in other parts of the world. The European Green Deal is to be a response to this. It is a growth strategy that aims to transform the EU into a fair and prosperous society with a modern, resource-efficient and competitive economy. And at the same time, the farm-to-fork strategy for a fair, healthy and environmentally friendly food system. All actors of the food chain must play their part in achieving sustainability.
In my opinion, European aquaculture is facing now the most important challenge of its history. Because it's considered the more sustainable animal production system able to guarantee food security for European citizens. The vision of the European aquaculture is to grow substantially in the next years, to have 1.5 million tons more of sea products in 2030. So this is a very ambitious target.
So starting here, what is driving sustainable aquaculture? Well, the first thing is that we see overfishing is a major issue, with 65.8% of fish stocks being at the maximum sustainable yield. And what this means is fish stocks are becoming depleted and less likely to rebuild, and that we can't produce more beyond that from commercial fishing. Yet we see that there still continues to be interest in fish production for food, and that global consumption has risen over 122%. While a lot of this is in Asia, what we are seeing as interest is expanding protein consumption of fish globally. And the last thing, as a result of all of this, we see aquaculture is rapidly scaling up with over 527% increase in the past 30 years.
But we see that in Europe, aquaculture is stagnating because of several reasons. And EDIB is providing a stimulus for research and innovation in order to ensure sustainable growth, but also a sustainable industrialization and an innovation of a competitive sector.
So wild capture fisheries will continue to be a part of the protein supply from the oceans for probably a good while, even with the transition to healthier diets that are based on aquaculture facilities and maybe more people even going to the vegan lifestyle, where protein becomes less of, from sort of animal sources, becomes less important in their daily intake. And so as we transition towards that, and even as ocean biodiversity and actually abundance is maintained, we need technologies and we need other solutions to make sure that we're doing that in a sustainable way, and that people aren't left out who do require fish protein in order to sort of survive on a daily basis or even profit from it in terms of industry and their income. The innovation that we work on, I mean, if you look at the different areas in aquaculture, innovation in wild fisheries in particular sort of tends to be in three different sections. So for us, it's around the gear-based and selectivity side of things. How do we catch the right fish, only the fish that we want to make sure that it's sustainably sourced and that the biodiversity of the oceans is maintained? We do that using our device called Pisces, which is a light-emitting device, which uses how different species respond to those lights to attract and repel them from fishing gears. This means we can reduce bycatch by up to 90% by applying Pisces to different fisheries. And that's the first product that we've taken to market with Pisces, which is a hardware as a service. We send the kit out, we provide the science around it, and also the maintenance to make sure that those fishing operations that use them can be much more targeted and much more sustainable.
We talk about precision aquaculture, understanding more about what we do. We work with batches of fish, of course, or shellfish or other species. And one of the clear opportunities that we have that we haven't solved already is to look into real-time biomass, especially of fish populations that we have. As we work on land-based systems or further offshore in big fish farming cages, then estimating in real time the biomass that we have in any one system is absolutely crucial to understanding feeding, to understanding the makeup of the population, understanding how we can better program sales, harvesting, etc., etc. There are several options or possibilities, but there is nothing operationally today, even in Norwegian salmon sector, that gives us this real-time biomass.
I think we really have a chance here to build a more sustainable food system in Europe, and aquaculture has, in our opinion, a clear role to play. It's able to produce healthy, safe, tasty and affordable food. It's, in comparison to the other proteins, a fairly low carbon emission food source. So in terms of climate risk adaptation and mitigation, it's a really important tool in our toolbox. And some subsectors of aquaculture are able to actively restore biodiversity.
Aquaculture is also entering new environments. It's moving further and further offshore into deep water and more exposed locations. And at the same time, it's moving onshore into land-based facilities. And this takes a lot of the environmental pressure away from our fragile coastal ecosystems, but it presents a lot of new challenges to both scientists and engineers. At Mattis, for example, we are using recirculating aquaculture systems. And this allows us to reduce the amount of water that we use. But it also means that we can grow tropical species like tilapia here in Iceland. And these systems use a biological filter to clean water so that we can reuse it. And this biological filter is made up of bacteria that can break down things like ammonia and nitrite in the water. But that means that we really have to have a good understanding of the bacterial diversity in that system, and also how it changes depending on the environment, be it different salinity or water temperature, so that we can overall optimize our performance.
The aquaculture market is a fast-growing market, and the amount of fish consumption has been multiplied by 10 in the last 2 decades, and in some regions in the world, for example, Latin America, it is foreseen that it will increase by 33% in 2050. Putting all these things together, we have focused our strategy in the development of solutions for small, medium-sized farmers located in Latin America, especially in Colombia, in the Cauca Valley. And for that, we have just launched a project, Aquaculture, which is funded by the Inner White program, in which we will co-create, co-work, and co-develop a solution for the water filtration of the fish ponds for these small farmers in Cauca Valley. For that, we are working together with a cooperative in the valley, which is formed by 23 farmers. And in the frame of the project, we will prove a small-scale pilot there, in situ, in one of the farmers. The results of this project will be the base for scaling up the solution in order to make it commercial, marketable by biofuel, and support us in our internationalization.
In the future, we should be able of generating a more positive public perception through different ways, by reducing the impact of aquaculture on the environment, by finding alternative treatments, vaccines, and diagnostic tools to fight diseases in a more sustainable way, and also improving animal welfare and farm biosecurity procedures, and finally improving food safety and traceability of the aquaculture products.
I have a lot of interest in particular with microalgae, but also with macroalgae as well. So the microalgae are these sort of small green unicellular microscopic green algae, or sometimes red algae, and the macroalgae are quite commonly what we call the seaweed. So this here is a usual sort of seaweed that we find on the beach. So we do a lot of research in Cambridge in particular on the microalgae, looking at how we can use microalgae to improve feed, sort of feed stocks, and for nutrient bioremediation or waste bioremediation for a lot of the sort of aquaculture industries. So again, taking nutrient sources from one industry, growing the algae, then using the algae as a feedstock because they're very high in protein, sometimes high in lipids, antioxidants and pigments that might be useful for other organisms, such as whether that's salmon, insects, cattle, and of course humans as well.
Several of the species of microalgae that we cultivate and produce here at the ITC actually are very promising as feed for species of commercial interest in aquaculture. But what we think is very critical right now is to be able to demonstrate the viability of these processes, especially from an economic point of view. To be competitive in this field and to really encourage the use of microalgae in aquaculture, we should be able to guarantee the best possible efficiency in the use of resources such as water, energy, nutrients, and for instance, using nutrients from wastewater, CO2 from flue gases, but also trying to improve the water efficiency of the production processes, for instance, by using alternative sources of water, such for instance, the brine or desalination concentrate.
EIT Food hopes to foster programs that attempt to solve these challenges. So how can you and your organisation, in collaboration with EIT Food, begin to tackle these challenges?